This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME podcast. I'm your co-host, Dan Blewett. On today's episode, we've got, some exciting news. Number one, Rosemary Barnes will be joining us here today as our new co-host. So, Alan, I don't know, what do we have to do? Tri-hosts now? What happens here? I don't know.
I don't know how that works, right?
We're
in
new
territory.
But yep, it's going to be great. So we'll hear from her in a second. Today's episode is going to be pretty exciting. We're going to talk about battery tech. We're going to talk about this terrible Chinese offshore installer vessel that is capsized. So we'll talk about the implications of that. I mean, so much offshore wind is getting going now where, there's going to be accidents like this. So we'll talk about the implications there, some projections and some ideas about engineering as we add offshore wind turbines. A really interesting case study of an Oklahoma wind farm that's had a lot of problems with safety and damage. And we'll talk about Anschutz investing in a Wyoming wind farm, which is pretty interesting that more and more of these fossil fuel companies are getting into renewable energy. And lastly, we'll talk about iron air batteries, which is a really exciting development and potentially has major implications for the grid. Before we get going, I want to remind you that we need to get you signed up for UPTIME Tech News. So if you're interested in the podcast, if you've been a long-time listener, it's time to sign up. In the show notes, you'll find a link. You'll just get a weekly email from us that says, hey, we got a new podcast. Here's what it's about. Here's some other great news from around the web. So definitely sign up for that today in the show notes, wherever you listen. So here are my co-hosts. First, let's introduce Rosemary Barnes. This is your first episode back since you were a guest way back when. So, Rosemary, welcome back to the show. We're excited to have you. Can you give our guests who maybe haven't caught your episode, or obviously it's been a couple months, could you just kind of give us a quick rundown of your background and part of the reason we wanted to have you on the show is your expertise in wind energy and renewable energy. So what do our guests need to know about you and the expertise you bring to the show?
Yeah, thanks so much for having me. So my career, I've been working developing renewable energy technologies for the last 15 plus years, and most recently in the wind industry. So I got a PhD in composite material structural design of wind turbine blades, and then the last 5 years until about a year ago, I was working at LM Wind Power. So they're a wind turbine blade manufacturer. So I spent a lot of time in their factories and climbing turbines and developing technologies for the wind industry. And then after I left LM Wind Power, I started my own consulting company, Partalote, where I develop renewable energy technologies and other sustainability technologies. And I have my YouTube channel, Engineering with Rosie, where I talk about the whole energy transition and help my viewers to understand the engineering involved there.
Awesome. Well, like I said, we're excited to have you back here, and we've got a good show today, and I'm sure your expertise, especially as we cover, some of the grid challenges towards the end, the battery technology and the composite stuff, that's going to be right up your alley. So excited to have you back. And then, Alan, how are you, sir?
Doing great. We're just living through the rainiest season in Massachusetts recorded history. So we're pretty much in the offshore business right now because we're just completely flooded out here. It's crazy.
Well, here in DC, all we have is just mosquitoes, all the mosquitoes you could want. So, pick your poison, I guess. But first on the docket, Alan, we heard about this jackup vessel tilting while installing an offshore wind farm in China. There's 4 missing. It looks like they haven't been found as of, it looks like a week later. Are we going to see more incidences like these?
Well, you'd hope not, but I think until we develop the procedures and the safety situations in which wind turbines are going to be installed offshore, the answer is going to be yes. In this particular case, we were just watching the video of it again, And it's just amazing that that accident happened. But in the rush to finish a job, you know how it gets when you're in construction, you're trying to get things done and get it all put together. Sometimes safety is not the number one priority, and then that's when accidents happen. So it's really disappointing to see it. But hopefully, unlike some of the other wind turbine things we've seen in the past, where there's been an accident and the industry hasn't really glommed onto it and learned from it, and when you start losing people, we need to take a good safety look at it and make sure that the safety implications get transferred to other offshore installations. So,
Rosemary, you've worked with, on big projects like this with, big corporations in wind power. What falls through the crack? Obviously, like anything can happen when we're in the open seas, right? But I mean, would you say that things like this seem like maybe a slip in procedures, or is it just this stuff is just going to happen every once in a while in a business like this?
I don't think it can happen once in a while. I think that would be the end of the industry if this started to happen regularly. So I'm sure, I hope, and I'm sure that there will be an appropriate response to this. But it doesn't necessarily surprise me so much. I mean, I've never worked offshore, but any of my colleagues that I have that have worked offshore and I've spoken with, they all have stories of near misses where they're watching the wave high, they're watching the buoys, the buoys for Americans. They're watching them, the wave height, and seeing that it's coming up and up and up. But, there's so much pressure onshore as well. You've got to find that weather window to be able to climb. And if you've got something urgent to do and you know that this is the half day where the winds are going to be low enough that you can get in there, then there's, an immense amount of pressure to get that up. And you think that's just going to be dialed up for offshore because you've got more pieces that need to align to make good conditions right for a safe climb. And each turbine is just, so much more costly to have downtime. So I can see that the pressure must be so much more immense to climb and to push the limits. And obviously they pushed it too far with tragic consequences. But I think that the response will be, the offshore oil and gas is known for its just intense safety culture because there's no tolerance for anything to go wrong out there. And the same thing will have to happen with offshore wind, which will no doubt add a bit of cost and especially pain for new projects. If you can't, you're trying to do something new, if you can't get out there to maintain, then it really makes timelines blow out. So it's going to be a hard balance, but you can't compromise on safety to the extent that people get killed every now and then. There's just no way that that's going to be acceptable to anybody in the industry or outside of it.
Yeah, and that's a good point because we've talked a bunch in recent episodes that we gotta throw 6 million more turbines into the ocean as fast as we can, right? Like everyone seems like they're scrambling to do things as quick as they can, but they can only go as fast as the safety, allows them to.
Yeah, and Dan, is there a regulatory body that was going to monitor all of that? I know every country is going to have its own regulatory system, but I don't know if there is one in the United States, especially once you get a little bit offshore, like we're talking about in international waters or federal waters, I guess. Who's going to oversee all that? Because somebody's going to, in the United States, we would never let that go. There's going to be somebody overseeing it. It sounds like they need to spool up. Yeah,
I don't know the answer to that. Rosie, do you know, is there a bigger regulatory body that the global?
Every country obviously has work cover or work safety systems in place, and every country where I've climbed, there's definitely a body that would come in and shut down a site if that was if that happened. The question about being in international waters, I don't know, but again, like oil and the offshore oil and gas, I mean, it's got to be the safest industry that exists on the planet, or they spend the most effort on safety there. So I don't know, whoever monitors that, maybe.
Well, speaking of more installation, the UK is planning to install 40 gigawatts of offshore wind power by 2030. And this interesting article by theconversation.com, which I'm not familiar with that website, but they had some good stuff as I was puttering around there. They said basically this will require 5,000 wind turbines, double the number installed worldwide offshore by the end of 2020. And to get to this number of maybe 30,000 turbines by 2030, there's just going to be a lot of engineering breakthroughs that are going to have to happen to make this feasible. Rosemary, I'll throw this to you first, but do you feel like that's fair, that there's going to be a lot of, or do we have sort of enough of the floating platforms and the rigging and enough know-how from fossil fuel industry to where maybe it doesn't take that much more to get over that hurdle?
Well, I think definitely they've learnt a lot from that offshore oil and gas, so that's going to give it a head start. But probably more importantly is everything they've learned from decades of onshore turbines. So it's not like, when they put wave energy devices out at sea and they experience all these problems because it's brand new. You don't have that with wind energy because the vast majority of the problems have been sorted out through decades of gradual evolution. So I think we've got that head start. But that said, there's going to be teething problems for sure. And especially we haven't really seen floating offshore yet. There's, a couple of pilot projects, but I think we can expect to see turbines occasionally tipping over, and especially installation times blowing out on projects from time to time as we figure out what are the new challenges that need to be taken care of with each project.
Rosemary, do you think there's enough engineers in those areas to even support that kind of output? It seems like it's almost an impossible task.
There's never enough engineers. And, the companies I was working for before, there was a huge shortage. And now I'm consulting, and every company that I work with, they've got a huge shortage in engineers. And I don't know if that is just like in every industry, that's the same. But I think definitely for any kids thinking about what to study at university, at college, then I think that engineering, renewable engineering is probably a safe bet for continued employment.
Yeah, and that's what's really interesting, as the world continues to evolve, because here in the US at least, college is looking like more and more of a, do I need to go? Can I just get a certificate? Can I do this digital thing? I advise some of the younger kids, I used to work with, baseball and softball players a lot in my previous lines of work. And we had that conversation. We're like, look, you don't have to go to college to be successful. There's a lot of other things you can do. That's always been true, like with trades. But it's probably more so now than ever. There's just lots of different ways to make together, or to cobble together a living, or just do lots of different things that are very skill intensive on the web, where, hey, if I'm not going to engineering school now, I'm never going to be on that track. So it might be harder to get kids just, because to get on the engineering track, you at least have to be at a 4-year college, to start, right? But if you're staying home doing a certificate or doing something else, in this digital economy. Alan, do you feel like, obviously your son Adam just graduated with his degree in engineering. Do you feel like even his generation is starting to slow down as far as enrollment?
It's interesting because I followed the group of kids. We live in a small town, so I followed the group of kids since they were essentially in kindergarten, first grade, till graduation, and now out of college. And it's interesting because I live in a town which is very university centric. It's a university town or a college town. There's a lot of professors that live in town, and the children of professors, you figure, are going to go to university. And that has changed dramatically over their lifespan over the last 20 years, because a lot of them have decided not to go to university or college. They're doing things, they're traveling the world, they're doing things that I did not expect when they were 10 years old. So you're seeing, I think you're seeing a real shift, and I think the cost of college is part of that. But if you're doing something technical like Rosemary and me, you have to go to college. There's just nobody's going to let you loose in an engineering place, a facility, without having the degree to go with it, just because there's so many implications on safety. And
it sounds like you're saying that I can't get a Google certificate and be an aerospace engineer in 6 weeks. Is that right?
Well, I don't want you working on my airplane.
Fine.
But you can be a wind turbine technician. There's also a big need for wind turbine technicians.
Right.
So, and that is also a path. I know it's not so common in Australia, maybe the US, but in Denmark, so many of my colleagues had a trade. First of all, they were an electrician or a carpenter, or even a farmer. And then later in life, they went back to university, got their degree, and now they're, some of them the best engineers because they've got both both sides. They know the hands-on stuff as well as the, like the mental stuff. So that's another option.
Well, we get requests all the time through the website that ask about being a wind turbine technician. And some of the articles we have posted on our site also talk about being a wind turbine technician. And that's one of the things about it is, and when people ask us this question is, how much does it cost to be qualified to work on wind turbines? It's actually not that much compared
Definitely
to...
a lower barrier to entry than a 4-year degree in the U.S. now, which is... in many cases, like, I have a degree in philosophy. Kids, it'll be good for your brain. Hey, high five. But may not get you employed right away. I don't know. That's also a changing conversation, because there's a lot. I feel like in the U.S. there's been much more emphasis of, like, do accounting so you can be an accountant, right? Do this so you can be that. Whereas it seems like almost it's becoming a little bit cyclical, where now it's like people do like the philosophy majors because they have a kind of wide skill set mentally, where they can, like, think on their feet, they can problem solve. You can kind of leave them alone. They can write a technical paper. They don't need babysitting, right? Because you learn those skills in that major. It's interesting how you see this stuff come back over time. So moving on, I mean, speaking of safety, interesting article from the Oklahoman. So for those of you who are global listeners, Oklahoma is in the American Southwest. And, Alan, is it still in the Midwest? Where did I say it right?
I would qualify it Midwest. It's just north of Texas. There's Texas, Oklahoma, Kansas, Nebraska.
All right. So it's in the Midwest. It's in a very flat place of our country. But there's this crazy old wind farm that, if you've seen any of these images floating around the web of a wind turbine that looks like it's wilted, like it's literally melted in the sun, or that the nacelle has caught on fire and just burnt to a crisp, there's a good chance that those photos came from this wind farm. So it's been sitting around for quite a while now, and just, like, sort of looking very haphazard, B, looking like a risk, because, like, hey, are these blades just going to fall off any given day? Like, is this tower going to topple over? But they had a lot of problems with lightning. So this was it was in the Oklahoma Panhandle. This was the Novus 1 and 2 wind facility. So it sounds like they're working on getting these fixed and getting this either back into service. Not maybe all of the turbines, but many of them. Rosemary, how often do you see stuff like this happen? I mean, is this common, where you see a wind farm that's been just sort of decimated by lightning and just by this much damage?
No, I never saw something like that before. I was shocked when I had a look at that article. It made me really sad, actually. You see one of those wind turbines that looked like the blades of bananas, and it was just the peels left, and it was kind of like that was the saddest thing I've ever seen, wind turbine wise. And you'd say it's old, but the article said that it was commissioned in 2012. So I mean, it's not that old. And when they first started to have problems, it was probably quite new. So the manufacturer is not in. They're not operating anymore, and perhaps that's a good thing. But there's obviously massive problems with their design on multiple levels, because it wasn't like, it was just lightning for all of these turbines. There's clearly a few different things that have happened. So I don't know, getting it back into operation, how do you even go through with the manufacturer doesn't exist? So how do you get access to all the information that you would need to be able to even know where to start to fix these up? And I mean, obviously they passed certification at some point, but, I would want to see most of that redone, because I don't want to be anywhere near this wind farm when it starts up, unless, it's really been gone over with a fine-tooth comb.
Well, Rosemary, does that have implications for offshore wind also? Just thinking about the time frame in which that happened and the sort of the resulting problems that they had since then. If you're going to install a lot of offshore wind, like we're talking about in the UK, do you start selecting vendors and OEMs based on that track record? Because it's going to be a cost thing, right? Is that the OEMs that produce quality wind turbines know that, and they know that the downside risk is massive for a country that's going to go wind energy wise, versus someone who's new on the block. what do you think that they're going? How does that even get played out in terms of buying a wind turbine?
Yeah, so I've worked through that process on a few projects with brand new technologies. The banks are really nervous, and maybe because they've learned through experiences like this. Obviously, someone lost a whole bunch of money on this wind farm, right? So the banks really care about the technology, and if it hasn't got a track record, then the banks will send teams of people to come and grill the engineers working on it to say, this could go wrong. What have you done to make sure that that's not going to happen? What's your test program like? What's previous versions of the technology, and what have you learned from them? So they're trying really hard to minimize that risk. And ideally, they won't be just putting out 100 turbine wind farm for, a new manufacturer would not start their offshore journey with 100 wind turbines out there. They would start with one, ideally. And that's what you do see with, like when you hear about the floating wind projects, for example. It's not like, oh yeah, here's 100 turbine wind farm. It's like we've taken one out there. And then hopefully the next time you'll have a few, because obviously you learn different things from different sites. The ocean and the wind aren't the same everywhere. But yeah, you got to do it a little bit gradually. And they have learned so much. Most of the problems they are well aware of from the onshore. So it's the new offshore specific problems that are the main ones that they're going to have to deal with.
Well, how valuable is certification in terms of the one? I mean, obviously those wind turbines had to be certified, quote unquote certified, and pretty much all wind turbines are today. But do we have that feedback loop that the certification we did on a new wind turbine is actually working? Because you're not going to, the worst that's going to happen is what happens in Oklahoma, that the wind turbines just catch fire or they stop operating. In terms of a grid or safety or a community, it doesn't make that much difference. So what I'm wondering is, how does that certification then get readjusted, or is it constantly evolving over time, and so we're learning things and putting it back into certification so the next one doesn't have that problem? Because it doesn't feel like that quite yet.
It's definitely evolving, but it's behind the manufacturers because obviously they can't respond to something that hasn't happened yet. And I know that most design engineers will tell you that certain parts of the certification are unnecessarily strict. They're requiring standards that don't really correlate to the field, but the converse is true as well, that there's some standards that it's kind of widely assumed that just meeting the standard is not enough. And the manufacturers are really driven by, the performance of their system. And I think that the biggest example of that is Lightning, which you're obviously familiar with that. They're all certified, but most Lightning engineers would not say just because you've got a Lightning certificate means everything's going to be fine. You also have to, design based on your field experience. And it's usually quite a bit above. Like, it's easy to design something that can get certified, but not as easy to design something that's going to be very reliable in the field.
In our next segment here, let's talk about GE. So they have just released a press release that LM Wind Power, which they own, is essentially completed a automated blade finishing program. So Rosie, obviously you've worked for LM, you've been there. You know what this process looks like, and how much manual labor is in it, how much robotics and automation they're working into it. But it says that their vision is to leverage, a lot of the things they've learned over the years, but to just start to decrease costs by doing some of the trimming and some of these other finishing parts. So obviously, how much labor goes into, these final parts, and is this really as big a deal as they make it seem?
Oh, well, I was really excited when I saw this. I think that we need to get more automation in general in wind turbine manufacturing. And I do sort of feel like the industry was a bit against it. They sort of, had a big push 10, maybe a bit more years ago and sort of put it in the too hard basket. So it's really nice to see GE coming along and, giving it the resources that it needed to succeed. And I think that finishing is probably a really smart candidate for, one of the first processes to automate, because it's a hard job. It's a team of people with grinders, excuse me, they're all day in the same position with this big vibrating thing. It's very hard job. So I would love to see the grinding replaced. And then with the trimming, that's something where you can make mistakes and not necessarily. It's harder to detect maybe than some of the other potential faults that you can get in a wind turbine blade. So I think that's another really good process to automate to improve quality. And then the final reason why I like it is because, the leading edge, they're finished by hand, but it's also just the absolutely most critical part of the blade aerodynamically. And you're kind of just eyeballing it when you grind away, all the excess that you get in the manufacturing process. So automating that so that you can guarantee that the design intent is actually there. I think that's gonna give some aerodynamic improvements as well.
And are there any spots? Because obviously, when you talk about automation, there are some problems still that are just too hard for a robot to figure out. When they require some nuance, they require, maybe they change from one molding to the next. Are there any parts of the finishing process or just the process in general that you feel like that they might never be automated out?
I don't think there's anything that will never be automated, but I think that, there's going to be, you obviously start with the easiest, or the ones that give you the best return on investment now and then move to the harder ones later. I think a lot of the repairs, they don't just do the same repair on every blade. It depends what defect you've found. And so I don't think you'll ever totally get rid of human involvement there. And I think that will stay manual probably longer than a lot of the other processes.
And Alan, obviously, with airplane design and your significant background in the aerospace industry, is this something that they've been doing for a while? Is this something that they've been coming around to just the same? Is the wind industry behind or ahead, or is this just sort of in a different category by itself?
They're about at the same place right now. There's not a lot of robotic painting going on besides Honda Jet and the military. Those are the two places where you see it. And Honda Jet's a relatively small aircraft, but the consistency of it is why they're doing it. And obviously Honda, as a corporation, puts a lot of emphasis on quality and looks and finish. So that makes sense from an airplane standpoint. But at least to my knowledge, like Boeing or Airbus they still have people crawling around on airplanes, painting airplanes. So the wind turbine industry doing it is a little bit odd. I kind of wonder if it has a lot to do with durability too on the coatings, that unless you get a very consistent coating thickness and also cure time and making sure that everything is just right, I wonder if the coating durability is going down. And if you automated it and get very consistent with the way the coatings go on, can you extend the life of the coatings, particularly around the leading edges and some of the places that historically wind turbines have had problems? And on airplanes, that has been the case. A lot of times on airplanes, when you go to an airport and you see an airplane, that the paint just looks awful. Most of that has to do with the prep of the surface and the application of the paint. That extends houses, cars, boats, are all the same thing. So consistency in the paint is really critical. You'd be surprised how much technique there is involved in that. And doing it robotically sort of takes the variability out of the system, so you can get better results. And it makes sense for GE to do it. I just don't know how much money they would save in terms of labor. Maybe there's some cost savings in terms of materials because you want to use less of it. That's one of the points. It's an interesting thing for GE and LM to take on, honestly.
So moving on, and this was a talking point from our last couple podcast episodes about how, whether or not fossil fuel companies are going to start to diversify or maybe just, slowly convert into more of either just an energy corporation or a renewable energy corporation. So Anschutz they're sort of the parent company behind Transwest. Transwest is creating a 732 mile high voltage power line that's going to carry power from, Wyoming all the way down to Las Vegas. And so this is interesting because Anschutz has been, they've made their fortune essentially on shale deposits in Wyoming, and they're traditionally a big on fossil fuels. So now, as we look to them, as they're starting to really heavily invest in Wyoming wind, is this another company? I'll throw this to you, Rosie. Is this another example of fossil fuel companies seeing the writing on the wall, or is it just them trying to diversify and maybe just hedge their bets and kind of wait and see what happens?
Well, I think that they do see the writing on the wall. And I was actually talking about this with somebody the other day about the difference between fossil fuel companies and the governments that have traditionally been influenced by fossil fuel companies. And I'm actually pretty excited that we've gotten to the point now where even fossil fuel companies can see that the only way to, ensure they're still making money in a decade's time is to get on board with renewables, because the economics is just there. The world is clearly going in that direction. And I think because, they're a company and know they'll be here, or, they really want to be here in 10 years' time, it gives them different incentives than governments who are much more capable of just ignoring anything that's, more than 3 years in the future. So I actually think that this politically is going to be really great, because presumably they continue to put pressure on governments, which has been terrible in the past for action on climate change. But at least now we've got, more and more of the people trying to influence government are pushing in the same direction for renewables. And nobody really likes to see fossil fuel companies rewarded for the damage that they've done in the past. But if I think practically, I think that their involvement is a real just sign that the momentum is there and the clean energy transition is happening no matter what.
Alan, do you see it that way?
I think there's real long-term investment look at what the large companies are going to do, right? So in this particular case, you're trying to diversify out because politically in the United States, you're never sure what's going to happen, right? Ergo, we had Trump and now we have Biden. So there's this complete opposite of the spectrum in terms of policy. So you need to play both sides. And I kind of wonder if it makes sense to really be in both, because you just never know what's going to happen next. Every 4 years, you're going to have the same sort of flip-flop. I see that coming again, honestly. The thing about this project, which I think is interesting, is where they are developing it at and where they're driving the energy to. So they're taking it from Wyoming, and if anybody's been to Wyoming, it's pretty open space. There's not a lot of people in Wyoming. Obviously, they're going to Las Vegas, where there's a lot of lights and things, but there's not that much need for that much more additional power. And obviously, Las Vegas is like a break point where they can transmit it to Southern California or somewhere else. But I also kind of wonder, too, if Nevada's super happy about this, because Nevada is making the play to be the next California. So everybody in California that doesn't want to pay $5 for gas or have the state on fire like it is right now is moving to Nevada. And Nevada has a lot of the water that California uses. So Nevada's sitting pretty. They just need some electricity, and they're the new California. So I kind of wonder if it's more of a state play of Nevada positioning itself with Tesla going to be moving out somewhere, and Tesla's already in Nevada, that the more electricity generation you can pump into the state, particularly renewables, makes it much more, it makes it easier for a company like Tesla to leave California and to show up in Vegas or Reno or wherever they want to go. So this is like a multiple level play, I think. And that's what makes it interesting, is that there's so many facets to this deal. And all it takes is one of these little dominoes to flip over and the whole thing collapses. But there is a big shift in the United States on where energy is being created and where it's going, which sort of shows you where the future population centers will be.
All right, so in our last segment today, we're going to talk about iron air batteries, which have been in the news cycle. There's Form Energy is a startup that's backed by Jeff Bezos, and they've just released some of the information about how their technology works, which I'm going to let one of you engineers explain to the world. But the real breakthrough here is that this is they're hoping it can get to 1/10 of the cost of the storage cost of lithium ion, and it's going to be a longer duration in comparison to lithium ion. It's not necessarily going to be a true long duration, but fall somewhere sort of in the middle. So Alan, how does iron air battery storage work? Let's start there.
Well, it simply takes iron powder and air are the two anode cathode to the battery, and then it has an electrolyte in the middle, very similar to an alkaline battery you buy at Walmart or somewhere. And that makes a battery cell. So the way, if you think about it very simplistically, the iron turns to rust from the oxygen from the other side. That's generically how it works. And then if you apply electricity the other way around, you turn the iron rust back into iron and oxygen again. So it's a reversible process, and it'll store energy for a relatively long time, unlike the lithium ion batteries that are in your iPhone, which last a couple of hours, relatively speaking. So Form Energy, which is doing a lot of this work, is saying, hey, this is not a permanent storage solution, but it is long enough that you could ride out some peaks and troughs in the grid in case you had a freezing event in Texas. You may be able to get through it, because they're saying roughly 100 to 150 hours is their sweet spot for this battery technology, which would make a huge difference. And as Rosemary's going to tell us, that's a huge difference, because you can essentially store energy that you generate from solar and wind during the daytime and use it at nighttime, or use it to do other fancy things. And I think that is where this is going. The real trick to it is all the financial business stuff on the backside. So the technology is cool, but the business side is really fascinating too. So, Rosemary, can you explain it a little bit more?
Yeah, well, I mean, I'm really excited about the potential of it. I think it is early days. Maybe, when you dig into it, it's maybe a little bit earlier than you might get the impression based on some of the reaction, which is, the case for any new energy technology you ever see reported. It always turns out to be further away than you think. So I think that their first prototype plant is going to come. They're planning to come online 2023. So it's not imminent, but on the other hand, obviously they've worked through the vast majority of their issues before they would be at the point where they could be planning, I think it's a 300 megawatt battery to start off with, which is, large for what I would call a prototype. So I think they're calling it a pilot plant. So it's really exciting. And the length of the storage, I think, is really good, because in high quality renewables areas like the Australian, East Coast grid, and like actually in California 100, 150 hours, that's going to get you through like nearly every single kind of downtime that you might have. It wouldn't be necessarily enough for somewhere like Northern Europe, where they have much bigger seasonal variations. But, for those of us lucky enough to live in places where the sun shines nearly every day and the wind, doesn't stop for more than a few days across the whole grid, it's really, it's really perfect. Still waiting to see a few details. Like I haven't seen the round trip efficiency, the cycle life, and even the charge and discharge rates. I haven't seen a lot of detail on that yet. So I'm looking forward to, getting some of that filled in. But within a couple of years, we should know whether the hype is going to live up to expectations. But the potential's there for it to be really, really big breakthrough.
And Rosemary, one of the things that you read in the publications and what they're actually pushing out as information right now is saying that iron air batteries have a higher energy density than lithium ions. Like, it's not even close. That lithium ions can only store so much density-wise, weight-wise, than an iron air battery. But it does seem odd that the battery that they're creating doesn't have that energy potential, so to speak. Like it's not as efficient as the quote unquote theoretical. Is there more room for growth in this? Is it still early? Is it still really early? And this is just the first baby steps, you think?
Yeah, I guess it is. It is really early. We never even heard the chemistry until like a week ago. For me, it's also really interesting to get an alternative to lithium ion, because we need those batteries for portable applications still. Even though the energy density is better in this iron air battery, I don't think anyone's proposing to use it for transportable applications. So I have always wondered why we're using all our rare, there's a lot of minerals in a lithium ion battery that aren't going to scale very easily. Supply chains are going to struggle to keep up with the extra demand for all the EVs that are going to come online, and then using the same materials for stationary batteries. I think it's so great if we've got an alternative for them. Even if it wasn't, better than lithium ion batteries, it will still be an important addition, because it's going to help to funnel the lithium, the cobalt, even nickel, and everything else you need in a lithium-ion battery can go for where it needs to be portable. So I find that part of it really exciting.
Yeah, and I'll toss this up to either of you, but I think it's, you start to hear this duration thing. I think most of us, myself included, I'm not an engineer, you think of, all right, I have a battery in my phone, I have a battery in my laptop, I turn my computer on and the battery just discharges to power it. I've never thought of duration. So can you kind of explain for the layman out there, including myself, what do we really mean by duration? Like, why would I want a battery to be longer or shorter? And like, how does that, can you kind of give an analogy or something where like I said, the consumer electronics, you can maybe relate that to what we mean here with the grid?
So I think it's mostly not a matter of can a battery last that long. I mean, you could charge a lithium-ion battery, leave it sitting there, and then a week later use the electricity. But the economics wouldn't be there to do that. So that's why you see like a hydropower dam is great long-term storage, because you can add a lot of capacity to that dam without adding a lot of cost. So you can make the dam wall twice as high, get twice as much water in there. It doesn't cost that much more, but you've doubled your duration. Whereas for a lithium-ion battery, you just need double your duration and you double the cost. So because you just need twice as many batteries basically. So usually it's some sort of economic thing. There are in some cases, like if you're thinking about a thermal battery or something, then yeah, you're going to get losses over time. So it's not purely as simple as that, but generally it's an economic consideration, which is why it's kind of hard to grasp why we can't just use lithium-ion batteries for everything.
Okay, so it's the duration of storage without being used. Is that right? So I don't really care that my laptop maybe loses some charge over 5 days if I don't use it, because what did it cost me in my electric bill to charge my laptop, right? But if you're charging 300 megawatts of electricity and that's your business, and you lose 30% of it because it wasn't needed, and that's where it becomes really costly. Is that right? Did I summarize it correctly?
Yeah, and if you've paid a whole lot of money for a battery, you only make money when you discharge it, right? So if you are only discharging once a week, then you're making a lot less money than if you're discharging twice a day. So that's basically the equation that people financing battery projects are looking at.
Well, and just the reuse, the number of cycles that you can charge and discharge a battery is really super critical here. Because in an iPhone, when it dies, right? You can replace it. If you're talking about gigawatt hours of energy storage, you don't want to be constantly replacing the cells. You want it to be able to charge and discharge. And what tends to happen on other forms of batteries is slowly the chemistry decays. There's other types of chemical reactions that are happening simultaneously to the one that you want. And like in a lithium ion, eventually it won't charge anymore. As we well know, eventually a lithium ion after 4 or 5 years is essentially a dead battery. You can't do it. So from a utility scale problem, you want that battery to last 20 years without touching. I mean, this is your dream, right? That you can just put a real battery, an energy storage device out in the desert, and it can just sit there and I don't have to do anything to it because the chemistry is so simple that I have this money-making machine. I mean, that would be better than Vegas, right? If you have that sort of technology, you are like a casino. Every time you discharge it, you just cash in the bank, which is why the Bill Gates and the Jeff Bezos and the Tesla people are all congregating around this new business, because if it wasn't going to generate that kind of money, they wouldn't be anywhere near it. Now Bill Gates has got a little bit different story, but the others not so much. So you got to wonder that in terms of a long-term play, once you make that initial cost investment, it is then just playing the markets in terms of energy. When you discharge it, can you hit California up and make them pay 3 times the amount which is what Enron did back in the 90s, right? I mean, you're kind of building this sort of Enron situation because you're going to be playing the power markets, and the battery becomes inconsequential to your ability to manipulate and control power markets, which is where I think this is going.
Yeah, I love mixing Enron
What did Enron make? Enron made nothing. Enron was a trader, was a power trader. That's all that they were. Now, this is a little bit different because you're going to have to go out and form energy. He has to go create batteries and sell them. Someone has to buy them. But once you do that, where's your cost? Where's your infrastructure costs? There may not be any. Right. And because the demand for intermittent energy is going to be higher as we get into the electric vehicle explosion that's in theory going to happen, we're going to be charging cars at night. We're going to be generating solar energy and wind energy during the day. Somebody's got to store that. So there you go. There's your marketplace. And I think that's eventually where it'll go.
Was Enron ever a legitimate business though? Like, I want to clarify, and maybe they were, but
yeah,
obviously
sure.
They were a huge, it Ponzi scheme essentially?
No,
but did they actually do legitimate work for some time before defrauding everyone?
They're a power trader, but they're playing both sides of it, and I think that's what got them in trouble. Is they're controlling how much power or they want to deliver, particularly to California, and California had open rates, and so they would just hold it until California was desperate, and then they release it at $15,000 a kilowatt hour.
This sounds like the plot of a James Bond movie. Maybe in 2027, iron air batteries will be controlled by a villain named, I don't know.
Well, have we not said for the last 50 years, whoever can, if we could create the battery, you're going to control the world. That on the engineering front, I'm an electrical engineer by training. That's what everybody has said the money was, right? It's not on making iPhones. The money is in making a battery that has long-term storage, because then you can control the success of nations, and that's what it'll be, and you will become Jeff Bezos' money will look like nothing compared to this if they can pull it off. And I think that's, it's like nuclear power. It's one of those magical things that we never thought we could ever get to, and yet here we are. But the battery technology is going to be super cool. So
Rosemary, globally, do you see this kind of technology catching off? Obviously, this pilot project is going to be it looks like it's going to be in Minnesota. Great River Energy is a Minnesota-based company. I'm not sure if the project will be actually in Minnesota, but do you see this being first a U.S. thing? Do you feel like some countries will jump on this sooner than others? What do you see as far as like the global reach?
I think in general, the U.S. has already got longer duration batteries, or they're using them for longer durations than other countries. And I'm not 100% sure about the reason for that. So I guess that if that trend continues, then yeah, you would see it in the US first, and it's a US company, so of course it's easier for them to maintain new projects that are located there. So I'd say yes, but I think it could potentially be really beneficial in a lot of places. So we just got to wait and see how many unexpected problems they have in between now and their 2023 commissioning date. And but if everything goes the way the press release says, then it's incredibly exciting. And
is this going to change the complexion of the way wind farms are built? We talked about this big hydrogen wind plant that's going to be built in Australia. I'm sure you've heard. And I mean, is this going to continue to sort of maybe this trend of like, when we build a new thing on this site, it's going to be like this theme park. Like there's going to be a huge battery, a couple acres of battery. There's going to be a couple acres of wind. There's going to be ammonia. There's going to be hydrogen. I mean, do you see it continue to flesh out that way, or will it maybe kind of remain segmented?
Yeah, I mean, I think a really good battery, like something that's a lot cheaper and longer duration than what we've got available now. It's kind of in a way a competitor to hydrogen, green hydrogen, because a lot of people think of that as a way to smooth variable renewables, which I've personally always been a little bit skeptical that will end up being how it's used. But on the other hand, it will also support hydrogen in that, if you've got more battery storage, then you can run your electrolyzer 24/7, which is probably the only way to make good money from it. So it'll be interesting to see exactly how that pans out. But in general, both this, large interconnector that we just talked about, big batteries, all of that is just going to really turbocharge how fast we can go from, like 20% renewables to 90%, or even, like really with this battery, it will make it easy to go even further beyond 90%. So that's the exciting part.
Well, that's going to do it for today's episode of Uptime. Thanks so much for listening. Remember, in today's show notes, you can sign up for Uptime Tech News. So if you enjoyed today's conversation and you want to be notified of the next podcast episode drop, sign up in the show notes below, whether you're on YouTube, iTunes, Spotify, Stitcher. Be sure to subscribe to our channel on YouTube. Be also sure to subscribe to Rosemary's channel on YouTube. You'll find Engineering with Rosie on YouTube. She does a great job explaining so much in the renewable energy industry, engineering problems, all the whys behind wind energy, hydrogen, all that good stuff. So you'll find her links as well in the show notes. Thanks again for listening, and we'll catch you next time on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. This is why it just makes sense to install a WeatherGuard Strike Tape LPS upgrade the next time your technicians are going up tower. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.